Hello students, welcome to Educate. In the last video, we have discussed about ionization enthalpy. But few topics I had left by considering the length of the video. So now one point which left I have to teach here is in case of P block element, the heavier elements prefer to show lower oxidation state. But in case of D block elements, the D block elements prefer to show higher oxidation state. The P block elements have tendency to show the heavier elements of P block have the tendency to show lower oxidation state, while the D block elements have greater tendency to show higher oxidation state. Why that happen? We will discuss later on also. But firstly, this point write that unlike listen here. What happened here in case of P block elements? When you consider about arsenic, so what happened here? There will be 4F, not arsenic, antimony. So there will be outermost electronic constant 4F, 5D, 10 and 6S, 2, 6P, 6P3. So what happened here? In this one case, the outermost electron will be tightly bonded to the antimony. Here to the antimony, the outermost electron will be tightly bonded with the nucleus. So by providing here and among these valence electron, the s orbital has greater penetrating effect. Greater penetrating effect means s electron will be tightly bonded with the nucleus. The s electron will be tightly bonded with the nucleus. So by providing the energy, the s electron will not release from the 6s, but the electron present in 6p that can release. So the heavier elements of P block prefer to show 2 unit less oxidation state than the maximum oxidation state shown by any element of that group. And this phenomena is called inert pair effect. Okay, inert pair effect, maybe you have felt a lots of difficulty. Not only you, your seniors also, about the inert pair effect, which is nothing here. What is here inert pair effect? The heavier elements of P block prefer to show 2 unit less than the highest oxidation state shown by other elements of that group. And that phenomena is called inert pair effect. That phenomena is called inert pair effect. And reason for the inert pair effect is that since the heavier elements contain a number of electron in 4F or the 5F, whatever with the element there is. So the heavier elements of P block contain a number of electron in 4F orbital, which has poor screening effect. So the valence electron will be tightly bonded with the nucleus. And the s orbital has greater penetrating effect. So the s electron will be tightly bonded with the nucleus. The P electron will be also tightly bonded with the nucleus. But when energy will be provided, then the electron from 6p could release, but the electron from s orbital will not release, and hence there is 2 electron in s orbital. Hence the heavier element will show 2 unit less oxidation state than the maximum oxidation state shown by other element of that group. Let's see here, in case of D block element, why here heavier element shows higher oxidation state? Reason here is, greater be the oxidation state, more be the covalent characteristic. As we know, greater be the oxidation state, more be the covalent characteristic. So, to form the covalent bond, there be less requirement of energy compared to that of ionic bond. So, at less energy, these elements will prefer to show covalent bond, and during that bond formation, it will prefer to show higher oxidation state. Okay, so let's see here. Reason is what? Reason here, let's see about the reason. What is that? Okay guys, this one here. Now, that's we have discussed already. Now, one point also. In case of complex compound, if the ligands will do pi bond formation with the transition metals, when in the complex compound, if the ligands will do pi bond formation with the transition metals, then that will show less oxidation state. Okay, now let's see, we discuss about these two questions. Name a transition element which does not exhibit variable oxidation state. So obviously scandium here, scandium is a transition metals, zinc is also a transition metal, d block elements, but zinc will be not, because zinc is not a transition metals. So answer, that's why answer is scandium. Why not zinc? Is it that clear? In the option, in the examination of CUET as well as in NEET examination, there will be option of scandium as well as zinc both. So you will not have to respond on the zinc, because zinc is not a transition metals, and in the question it has been mentioned about the transition metals. So that's why only scandium. Now, which of the 3D series about that I have already discussed here, and I hope all of you could solve these questions very easy. Now, about the standard electrode potential, we will discuss in the next class. It's all for the today class. Thank you, Team Educate.